day to every student out there. Thank you for joining us on the maiden edition of the School on Air TV program. Now, I'm sure a lot of you are wondering what School on Air TV program is all about. Well, I would not let the cat out of the bag yet, but before then, let me introduce myself. My name is Fumi, and I'm not here alone. I've got my co-presenter also in the studio, and he'll be introducing himself right now.
My name is Tune. We're glad to welcome you to School on Air. It's an innovation as far as education is concerned in Nigeria, and it promises to be a great time, which you can afford to miss.
Yes, School on Air is basically an educative and interactive program for senior secondary school students. You're going to be exposed to video lessons of about up to 19 different subjects, and in the process, you're refreshing your memory and you're also experiencing classes in a totally different way. So it's going to be unusual. It's going to be, something that you've never experienced before. So I'm sure a lot of you are looking forward to it.
School on Air is an innovation. It's actually school at home. You have opportunity to be taught by seasoned and experienced teachers in all areas of your studies. Science students will have opportunity to be taught in physics, chemistry, biology, which are the core sciences, and then the social sciences, economics, government, geography. The arts are also not left out. Opportunities are there for you to have great teachers teach you in literature, CRS, and some other stuff.
Yes, that's very true. And do not let us forget to tell them that we actually have what we call the Watch and Win promo. So you're going to be learning at the same time you're going to be winning, because at the end of every lesson, we're going to have some questions for you to answer. So if you're one of our lucky winners, you get to win airtime and also lots of other goodies like that. So you're not just going to be learning, but you're also going to be winning.
That's very true for me. School on Air therefore provides an opportunity for a win-win situation for our students back home. You have opportunity to be taught, and at the same time, you have opportunity for being rewarded when you appropriately answer the questions that will be dished out at the end of each edition.
Yes, so you see that you have nothing to lose by joining us on the program. You actually have a lot to gain. So for today, let's quickly go to our lesson. We're going to be looking at a chemistry lesson, and I'll not tell you the topic yet, but you want to stay there and watch. So we will be right back. Don't go anywhere.
You are welcome to another interesting edition of the School on Air. And today, as usual, we're looking at chemistry, the subject of life. And in chemistry today, we are going to look at chemical formulae. Chemical formula, singular. Chemical formulae, that's a plural, with the addition of E. Chemical formulae, that's formulae of elements. And before a formula can be written, that means that substance must exist as a molecule. That's in a molecular form, or it's existing as a compound. That is a compound that makes up two or more elements, combining together chemically. So we use formulae for compounds. So from there, we look at molecule. A molecule of a substance is represented by the symbol of its component elements. That means a molecule is a compound, and a compound is a substance that contains one or two elements that are chemically combined together. So that means in that combination, there are component elements that make up such a molecule or such a compound. So for such a compound or molecule to be represented, there is a formula that is used to represent it. So such a representation is known as a chemical formula. That is when you represent a compound, when you represent a compound with a formula, or when you represent a molecule with a formula, call that a chemical formula. So a formula now can be defined as a collection of two or more symbols to represent one molecule of the compound. If you remember, in the last edition, when we were talking about symbols, we said then that a symbol is a sign, and it consists of a letter or two letters, of an atom, of an element. So here, a formula is used for a compound. So a formula can be defined as a collection of two or more symbols. That means you combine two or more symbols together to represent one molecule of that compound. So when that is done, you write a chemical formula for that compound. And so from Dalton's atomic theory, which states that chemical combination takes place between small whole number ratio of atoms. So from that Dalton's atomic theory, this can be said to be the power with which atoms are combining to form molecule of the compound. There is a power with which atoms combine. You call it the combining power of an atom. So the power with which the atoms combine or are combining to form molecule of the compound. That's the way it is represented. That's the way it is written. And it's from that we derive the chemical formula. This is called the combining power or valency. The combining power of an element, the combining power of a substance or its valency. So a particular atom may combine with one another in two or more ways. So for example, if you look at, say, hydrogen combines to give H2. That's one atom of hydrogen plus another atom of hydrogen will give you H2. One atom of oxygen plus another atom of oxygen will give you O2, and so on and so forth. So we can have such combination where a particular atom may combine with another atom in two or more ways to form a formula. It then follows that the atom has various combining power, while some atoms do not have the ability to combine with any other atom. While some atoms can combine with other atoms, there are some that do not have the ability. They don't have the combining power. They don't have the power to share with other atoms. So we are going to look at some of those atoms that can combine easily with the other and those that cannot combine easily with others. These atoms could be said to have no power at all. That is, those that cannot combine with other atoms. The power of atoms could vary from 0 to 7. It's just like in the periodic table. In the periodic table, where you have table of elements from group 1 to group 7, and those in group 0. That's those in group 0, noble gases. Those in group 1, alkali metals or elements. Those in group 2, alkaline earth metals, and so on and so forth. So the power of atoms could vary from 0 to 7 as deduced experimentally. And so atoms of various elements are classified now based on their powers. That's their combining power or valencies. There are some that have the combining power of 1, those that have 1, 2. There are some that have 3, there are some that have 0. That means their combining power is 0. So we are going to look at them one by one. Valency 0 atom or valency 0 elements. One, you have helium. Helium does not have any combining power, it's 0 combining power. Then neon, argon, Ar. Their valency is, they have valency 0. They are valency 0 atoms. Helium, neon, argon, they belong to valency 0. Then you have valency 1 atoms. These have the valency of 1. Their combining power is under 1, it's in 1. Hydrogen, number 1, has the valency of 1. Lithium has the valency of 1. You have fluorine has the valency of 1. You have sodium has the valency of 1. And these are the elements that are in valency 1. Potassium, valency of 1. Silver, valency of 1. Bromine, valency of 1. Iodine, valency of 1. Chlorine, valency of 1. Gold, valency of 1. They have 1 valency. Now we have those that belong to valency 2. valency 2 atoms. These are beryllium. You have beryllium, you have oxygen, you have magnesium, you have calcium, you have zinc, you have barium. All of them belong to valency 2. Their combining power is 2. They have 2 combining power. Then you have those that have the combining power of 3. That's valency 3 atoms. You have boron, first one there. You have aluminum, and those that are in valency 4. You have silicon. Silicon is valency 4, and you have those that have variable valencies. So we have been able to see the combining power of an atom, the combining power of a substance. That combining power of a substance is its valency, it's a valency. And there are those that have valency 0, they do not combine. Those that have valency 1, those that have valency 2, those that have valency 3, those that have valency 4. Now, of all these atoms, there are those that have variable valencies. Their valencies are not stable. Some have 2 valencies, some 3 can exist as 2, some can exist as 4, some can exist as 1, 2, 3, 4, 5, and so on. So we are going to look at a table showing elements of various atoms with variable valencies. 1, you have carbon. Carbon has the variable valency of 2 or 4. It can either be 2 or 4. That's nitrogen, can either be 1 or 2 or 3 or 4 or 5, like we are seeing in the table there. Phosphorus has a valency, can exist as phosphorus 3 or phosphorus 5. Sulfur can exist as sulfur 2, 4, or 6. Iron can exist as iron 2 or iron 3. Copper can exist as copper 1 or copper 2. Mercury can exist as mercury 1 or mercury 2. So these are elements or atoms with variable valencies. You have tin, can exist as tin 2 or tin 4. You have manganese, can exist as manganese 2, 4, or 7. Chromium can exist as chromium 3 or 6. Cobalt can exist as cobalt 2 or 3. Nickel as nickel 2 or 3. Lead as lead 2 or lead 4. These are some of those elements or atoms with variable valencies. Now, you have some formulae that are used for molecules, and the molecules occur differently. Some as a monoatomic, some as a diatomic, some as triatomic, and some as polyatomic. You have those that belong to the monoatomic group. Those that belong to the monoatomic group, you have helium, it's a monoatomic. So the formula there is He. You have neon, that's form Ne. You have argon, you have krypton, and those that exist as diatomic. You have chlorine, Cl2. You have bromine, Br2. You have iodine, I2. You have nitrogen, N2. You have oxygen, O2. You have hydrogen, H2. You have fluorine, F2. Then triatomic. That's 3 atoms are there. 3 atoms of oxygen combining together to form O3. So triatomic, oxygen is there. Polyatomic, those that have more than 1 atoms. You have P4, phosphorus 4, you have sulfur 8. These are polyatomic molecules. And so that means in those particular molecules, you have more than 1 atom. It is more than 1 atom that combine together to form those. Then for compounds, for example, water is H2O. Ammonia is NH3. Iron 2 chloride, FeCl2. Iron 3 chloride, FeCl3. Aluminum oxide is Al2O3. Aluminum oxide, Al2O3. You have hypochlorous acid, HClO. Nitrogen 4 oxide, that's NO2. Sulfur 4 oxide, SO2. These are the formulae of some of the compounds you have there. Then you have formulae of radical ions. Those radical ions, they are like ClO3, chlorate, trioxochlorate, 5 ion. The valency is 1. You have NO2 minus, dioxonitrate, 3 ion. That's NO2 minus. The valency is 1. NO3 minus, trioxonitrate, 5 ion. NO3, tri, 3 tri, 2 di, 4 tetra, 1 mono. So NO3 minus, trioxonitrate, 5 ion. Valency is 1. SO3 2 minus, 3 trioxosulfate, 4 ion. The valency is 2. You have SO4 2 minus. SO4 2 minus. That's tetra. 4 is tetra. Tetraoxosulfate, 6 ion. These are some of the formulae of the radical ions that you have. You have CO3 2 minus. Trioxo, 3 is trioxocarbonate, 4 ion. The valency is 2. You have PO3, 3 minus. Trioxophosphate, 3 ion. The valency is 3. Then you have PO4, 3 minus. Trioxophosphate, 5 ion. PO4, 3 minus. That's the valency is 3. Then you have Cr2, O7, 2 minus. Cr2, O7, 2 minus. That's hepta. 7 is hepta. Hepta oxodichromate, 4 ion. That's when you calculate when you find out the oxidation number, the oxidation state of chromium there. So it's hepta oxodichromate, 6 ion. You have Cr4 2 minus. Cr4 2 minus. That's Cr4 2 minus. 4 is tetra. Cr4 2 minus. 2 minus is the superscript raised to power 2 minus. Tetraloxochromate, 6 ion. You have MnO4 2 minus. That's from potassium permanganate, 4 tetra. Tetraoxomanganate, 6 ion. Then you have the hydroxide ion, OH minus. And then lastly you have NH4 plus. That's ammonium ion. These are some of the formulae of the radical ions that we have. Then chemical equation. What is a chemical equation? A chemical equation that we normally write, that means for a chemical equation to be written, there must be a reaction between reactants, and these reactants combine together to give products. So when elements or compounds or their combination are subjected to some external conditions, new products, which are elements or compounds, are formed. So in other words, for a chemical equation, for you to have a chemical equation, there must be a reaction. There must be a combination, either between elements or compounds, under some external conditions of maybe pressure and temperature, and then new products are formed at the end of the day. So those new products, the reaction between the reactants, those that combine, the elements or the compounds that combine to give the products at the end of the day, is normally represented by a chemical equation. So that's what we call a chemical equation. So a chemical reaction usually represented by a chemical equation to show how the transformation has been affected. That is, the transformation of the reactants, how the reactants have been transformed to give a result. That result, called the product, is represented with a chemical equation. So there are rules for writing chemical equations. Number 1, you write correctly the symbol of atoms of the elements and of formulae of molecules of the compounds undergoing the reaction. And after you have done that, you make sure that what you have on the one side, that's the left-hand side of the equation, is equal to what you have on the other side of the equation. You balance up by trying to use trial and error, by placing numbers in front of the elements and the atoms that are in the equation, that's the left hand side and the right hand side. Place all reactants on the left hand side. That's on the left hand side you have reactants, while on the right hand side you have the products. So that will help you to write an equation very, very well.
Welcome back, guys. That was a very, very informative and a very, very interesting lesson. I actually learned a lot, and I saw today he was so attentive while the lesson was going on. I don't know what he was trying to look at.
For me, actually, there is no knowledge that is lost. It was an exciting time.
All right, so let's quickly go to our questions for this episode. We have some questions for you to answer. Today we'll start with the first question.
So we take the questions on chemical formula. Question 1. The valency of phosphate ion is? I take it again. The valency of phosphate ion is?
The second question, list 2 examples of polyatomic molecules. List 2 examples of polyatomic molecules.
And the third question, calculate the oxidation state of nitrogen in ammonium ion. I take it again. Calculate the oxidation state of nitrogen in ammonium ion.
The fourth question, the valency of gold is dash. The valency of gold is dash.
And the last question, which is question 5, a good example of a triatomic molecule is? I take the question again. A good example of a triatomic molecule is?
So there we have it. Those are the questions for you to answer. Remember that if you are one of our lucky winners, you get to learn that by the end of the week. So go to our website, www.schoolonair.com, and answer those questions. And you can also send your answers to our WhatsApp number scrolling on the screen.
We are looking forward to receiving answers from you. And at the end of the week, we will announce the winner. It's been an exciting time on this maiden episode of School on Air. We look forward to seeing you in the next time.
Yes, it's actually been a very, very interesting time on the program. And don't forget that you can also go to our website, www.schoolonair.com, and you can buy and purchase materials, because we do not just have materials for secondary schools, we have for primary schools, we also have for junior secondary schools. So you would love to go to our website and find out more for yourself. Till next time, when we come your way again, from me, it's bye-bye for now.